Get that stupid camera out of my face! Why aren't you making me pretty? Why the hell isn't the screen down? Put the screen down! I said get the camera out of my face! I'm working with idiots. Oh, hello there. It's me from the last video. Over there we covered some of the basics, but today we're gonna be dealing with the big guns. Follow me. This is my observatory. Let's open this baby. This is taking too long. Let's fast forward the video a little bit. Oh, did you see that bird? It was so beautiful. It makes my heart beat. Uh-oh, I'm sorry, I got carried away. This telescope is a 12-inch Schmidt Cassegrain made by me. It has a 3-meter focal length. You know, people always say, after you die, you turn into a star. I come here every night looking for my baby in the sky, but I don't know, I just can't, I'm sorry, I'm getting carried away. Let's go back to the white screen downstairs. One amazing modern advancement in the design of large ground-based telescopes is adaptive optics. Large telescope mirrors are actually composed of hundreds of small mirrors. Each little mirror has a little actuator attached to a motor, and it can be moved by a computer. The computer observes a laser beam shot up into the sky, then analyzes how it is blurry and changes the shape of the telescope by moving each of those little mirrors to make that laser beam appear straight again. This removes the blurriness from the telescope image. Look at this footage, for example. You know how on a hot summer day the road becomes blurry and almost water-like. Well, the same thing happens in outer space, and we need adaptive optics to help fix this blurriness. In fact, it does this so well that some ground-based telescopes that employ adaptive optics actually perform just as well as the Hubble telescope. The very large array is in New Mexico. There are 27 of them facing in the same direction. Each telescope in the array is a radio telescope, meaning it can determine the strength of low-frequency emissions hitting their dishes, and do so with remarkable sensitivity. These 27 radio telescopes are arranged in a very large Y shape that fits in a circle 24 miles in diameter. Because many of the frequencies being observed have wavelengths several miles long, having such a large radio wave receiving area means very distant and faint objects can be detected. There are 2 telescopes far away, making it seem like they are telescopes with a huge diameter. For example, Keck Observatory. The Keck Observatory in Mauna Kea, Hawaii, consists of 2 optical telescopes a distance away from each other. Each telescope has a compound mirror, meaning many small mirrors act like one large mirror. Each of these compound mirrors have a diameter of 10 meters, making them the largest usable area telescopes in the world. If they take images or pictures while pointing at precisely the same part of space, the 2 images can be interpreted and meshed together with computers, making it seem like a telescope with a radius much larger than the 2 themselves. Its process is called interferometry and is the same used by a very large array, only the Keck Observatory uses interferometry with an optical telescope. There are 4 great observatories out in space. They are Hubble, Chandra, Spitzer, and Compton. I will talk about the first 3. Hubble, perhaps the most famous telescope on or off Earth, is an orbiting visible light telescope. The lack of atmospheric interference and light pollution allows it to take high-resolution images much better than most surface telescopes can. The Hubble takes images the same way any DSLR cameras do. A large sensor plate made of individual photosensitive semiconductor modules covered by colored masks can capture images projected into it by arrays of lenses. Chandra X-ray Space Telescope. It was launched in 1999. It does not orbit like other space telescopes. Because the Earth's atmosphere absorbs most cosmic X-rays, monitoring them from the Earth's surface is extremely difficult. They are, however, very important to understanding the energy cycles of many active astronomical objects. Chandra is the most sensitive X-ray telescope on or off Earth due to its large mirror. It orbits the Earth every 64.2 hours, an orbit much slower than most satellites. Not only does this allow the telescope to completely escape the atmosphere, but the slower speed at which it moves means images can be taken over a longer period of time without blurring. Now here comes my favorite one. The Spitzer. It was launched in 2003. The Spitzer is a very detailed infrared telescope. It is the last of the great... I'm getting carried away. It is the last of the great observatories. Infrared represents a fascinating portion of electromagnetic spectrum. It was thanks to IR radiation that humans discovered the atmosphere around Pluto, the rings of Saturn, and water in comets, during the crash of the comet Shoemaker-Levy 9 into Jupiter. Astronomers also used the infrared spectrum to gain glimpses of the early universe, to watch stars whip around in their ferocious orbits around supermassive black hole in the center of our Milky Way galaxy. It contains 3 observational instruments: the infrared spectrograph, infrared array camera, and multi-band imaging photometer. Here is an example of what the world looks like through an infrared lens. This is a picture of Ali without infrared imaging. Here's that same exact picture, but this time it was taken through an infrared lens. Wow, different, eh? The infrared spectrograph is meant to analyze the types of infrared being observed, while the infrared array camera does not discriminate wavelengths as much and is meant to serve as more of a traditional camera telescope. The third module, the multi-band imaging photometer, combines the functionality of the first 2 modules into one imaging unit. Because the spectral units in the spectrograph and imaging photometer require being cooled to very low temperatures to function properly, each was decommissioned after an onboard supply of liquid helium cooling was exhausted. As a result of one of the most incredible engineering success stories in human history, the infrared camera is still in operation today, even after running out of all of its helium in 2009. Thank you for watching. It really means a lot because I'm very passionate about telescopes. Very passionate about telescopes.
I've been feeling too busy lately just to stop and open my tired eyes. Now I'm looking around, what a surprise. The sun is shining, birds are singing, flowers blooming, look what spring's bringing. It's a beautiful day and I'm holding your hand. The sky is blue and streams are flowing, trees are budding,
sun is shining, birds are singing. Sorry, I got carried away.